Hello everyone. I'm gonna talk today about the Internet of Things, and specifically I would like to show you how you can quickly build the machine vision system, which will be additionally supported by the artificial intelligence. But before diving into details, let me show you a few slides about my work and my interests. So currently I am the senior researcher at the Polish Academy of Science, specifically at the Institute of Physical Chemistry. And what I do at the daily basis, I develop the prototypes for sensing and imaging in turbid medium, especially for the sensing the brain activities. And also we are trying to image through scattering layers, which is typically impossible, and we are trying to improve this imaging using the light modulation. So basically, if you typically shine the light through the scattering medium, you get the signal like that, image like that, and after some specific processing and modulation, you can recover what is hidden behind some layer. But don't worry, I don't have any tool like that now, so I don't see anything behind the clouds. But hopefully we can develop something like this soon. Apart from that, I also publish books and articles especially in the Programmista magazine. And there are some covers of the magazines in which I contributed. And recently also I started to record the video tutorials. And after hours, I'm just the ordinary parent, so I need to look after my daughter, digging holes for her, and also look after to avoid her falling down, and so she doesn't have bruises. So going into the main topic of this talk, let's first tell me what was the motivation of this talk. So basically, the machine vision is the part of the Internet of Things. There was a talk this morning which touched this idea. So maybe not in Eastern Europe, but in California, you may probably see very often the self-driving cars developed either by Google or by Tesla. But maybe more often you can see the cars which has automatic traffic sign recognition. And this is actually one of the examples where you have things, especially the machine vision, which process the input from the camera and tries to recognize the signs. So when you see the speed camera, you don't need to wonder what was the speed limit. You just look onto the dashboard and you can adjust the speed of your car without worrying that you will get a ticket. And the last motivation for this is the biomedical imaging, which I'm working actively. So this is like the main motivation for developing the machine vision. We need to, using the image from the camera, we process this data to extract characteristic features to detect some diseases. And here I'm going to focus on developing the low-budget IoT machine vision system using the small device which is called the Raspberry Pi 2. We've attached the additional add-on board, which has 64 RGB diodes, LEDs, which act as a display. And additionally, this add-on board has a 5-button joystick, which can be used to control the device, and a number of sensors. And this device is like the size of this device is like a credit card. And it has 4 USB ports where you can attach a simple webcam, which you can buy for $20. And also you can plug in wireless connector, so you can easily connect this device to your network and rapidly build the IoT solution. Moreover, this guy has the HDMI port, so you can even connect it to the PC and see, and it can act like a small computer. And here is the example of the system working. I have attached the webcam using the USB port, and I'm displaying the cross, which was detected by this camera. So all this machine was built with on top of the Windows 10 IoT Core, which acts as the operating system. It also possesses the API, which lets me to get an access to the image from the webcam, and also get an access to the internal sensors of the Raspberry Pi 2 and the SenseHut on top of it. And also Windows 10 IoT Core helps me to control what is displayed on this LEDs. And of course I need a webcam. Unfortunately, the webcam I used was a very cheap one, and the current version of Windows 10 IoT Core had a small frame rate, about 5-10 frames per second, but you can also get the slightly more expensive camera and have like 30 frames per second. And the app I developed has like 2 modes. The first one is the mode in which the app detects human faces using the API, which is implemented in Windows 10 IoT Core. And also, this app can send the image acquired from the webcam to the Microsoft Cognitive Services. And this service, specifically the Emotions API, process the data I provided, and it is able to detect human emotions. So this is like an example where I have a small device, IoT device, which acquires data from a webcam, sends it to the centralized cloud-based system, which processes the image and returns me a JSON, which tells me what is the emotion detected in the image. And the second mode is where I developed custom image processing using OpenCV. And in this mode, the app works like that it aims at recognizing simple geometrical shapes, which can be further extended to identify traffic signs. So how does the app works in the first mode? Here's the short movie which shows the preview from the webcam. Here is the preview, and when I press the Detect Emotion button, the image is sent to the Emotions API, and I'm processing the JSON to display the face position on the image and also detected emotion. So as you can see, depending on my emotion expressed on my face, the app can detect it and display the face position and also the emotion name. And moreover, if I don't have the display attached, the monitor attached to the Raspberry Pi 2, I display the color of the emotion. You can see that all emotions has the specific color of the rectangle. This color is also displayed on this array of LEDs on the SenseHut. So this is like, you can see that it's processing pretty fast. So it looks like that. So you can work in 2 modes. You can attach the monitor or see the result directly on the device. And as I mentioned, the SenseHut has also the button, specifically in the headless mode where I don't have the monitor attached to the Raspberry. I use the button to start and stop the image acquisition from the webcam, and also to send the currently displayed image for processing to the cloud. For the second mode, I have the custom developed processing based on the OpenCV library. And here is the example of how does this processing work. So the app has some kind of this sample app has some simple user interface, which lets you pick the picture. Here I have some drawn some simple shapes. And then after I run the processing, I detect all the shapes. And then to detect what is the specific shape, I can simply count the vertices in my contour. So basically, when you develop such an apps, in this case, I use the following tools. So firstly, I use the Internet of Things. So my thing is this small device, and Internet here was used to process face image to detect human emotions. So this detection is based on the machine learning and artificial intelligence, which is implemented in this emotions API. Then I use my Windows 10 IoT Core installed on the small Raspberry Pi 2. Then I have image acquisition and custom image processing. And as I mentioned, I use the emotions API from the Microsoft Cognitive Services to detect the human emotion. And what was the cost of this system? It's about $100 plus some free time. So going into more details, starting from the Internet of Things, why this topic is so exciting? It can be compared to what we had before before the internet was widespread. I guess that most of you remember the times where you had to connect to the internet using your phone connection, so it was very slow. But before that, you were working in the disconnected computers. So when you had to exchange some program or game with your friend, you need to take your tape from Commodore 64, take this tape to your friend, exchange the tape, and go back home. And now, when people connected all these devices into a global network of the internet, you don't need to go to your friend anymore. You just type in whatever you want in the Google, and it rapidly gives you the result. So apart from easy data exchange, you have like endless possibilities after connecting devices. So the same idea is in case of the Internet of Things, but except of desktop type computers or servers, you have small devices which can be this size, or even all of you have now the Internet of Things in your pocket. Your smartphone is also element of Internet of Things. It has a large number of sensors. But the idea is that how we can use the hardware we have already. So we can easily set up the monitoring system which analyzes the temperature or humidity using the sensors in our thing. But if we use many things, then we have a lot of data and how to process this data. So moreover, the IoT devices are very, very powerful. Comparing the current smartphone to old computer, the smartphone is already much more powerful. It has few core CPU inside. So having the widespread IoT adoption, as a result, we get a large amount of data, information to be processed. So how to handle it? We can handle it with the machine learning and artificial intelligence systems. And there are a lot of IoT applications you can find. Specifically this morning in this room, this topic was covered in more detail. Many applications were explored. I will just give the 3 examples. The first one is the smart city, where you can imagine the city where data from sensors where data from everyone's smartphone, everyone's car is going into some centralized system which processes this data and tries to predict accidents or future actions to avoid any problems. The other example is the healthcare, where we have sensors on our body, and data from the sensor is coming to the cloud system, which processes this data and may act as a predictive system, which may detect or avoid the disease. And last example is automation. When we go back home, we just press a button on the remote controller, and the remote controller triggers an garage to be opened, so we can easily drive into the car. We don't need to get out of the car and manually open the gate. And automation actually, probably unknowingly, is used every day. If we go back home, we also like set up some program on the any device at home, and it automatically performs some process. However, most of these automation devices, they are disconnected with each other. So now the internet, in the term Internet of Things, aims at connecting those devices into a global network. And you can even download today the complete IoT app, which uses your smartphone and OBD connection, and can, by acquiring data from your car, it can predict and score your driving skills. So you can download it for free and even most likely see how it was built on the appropriate source control system. So given all this data from the IoT devices, we end up with some algorithm which has to process it. So behind the IoT, we have the machine learning. So what is the machine learning? Of course, there are many formal definitions of this term, but like briefly speaking, is the ability of the machine to generalize what it has learned. So when we go to school, we are taught some patterns, especially during the math classes. And then, given these patterns, we try to solve other tasks. And that's the same with the machine learning. We provide some training data set to the machine, in which we specify what is the input data and what is the expected result. And then machine is, by analyzing this data, is trying to generalize it. So when we provide some unknown data, it tries to predict the outcome, to solve the problem. So more formally, it's an automated adaptive adjustment of model parameters based on the provided data. So what does the model and data means in terms of machine learning? Basically, data is the information coming from our sensor, for example, temperature, and the model is the function or set of functions or objects which tries to fit or predict our data. So briefly speaking, data is the reality and the model is the expectations. But as we know, the expectations may don't follow the data. So the machine learning system is the better if it is able to provide good enough expectations. So by generalizing this to the artificial intelligence, the AI is the system which takes data from many sensors or cameras and analyze this to take specific actions. So in my example, I have the device which processes the image from the webcam and then detects the human emotion. Of course, almost every algorithm we write can be understood as the artificial intelligence, but basically, because it's done in an artificial way using the machine, but basically, some of the well-known algorithms or tools, they are like coming from the AI to the normal world, so they are not artificial. They are not considered as an artificial intelligence anymore. And the good example is the speech recognition. It's so widely used that nowadays no one thinks about speech recognition as the artificial intelligence system. Moreover, the AI may include the speaker identification and language understanding. So how does it work, the machine vision on the Windows 10 IoT Core? So when you download the Windows 10 IoT Core and install it on the SD card, plug in to this device, and connect to the display, you will get a screen like that. So it shows some basic information about your board. And also, you can access your board if you don't have a display. You can access it using the so-called device portal, which is a web-based application. So you can type in the address of the device and then get a similar options as in the normal Windows 10 device prepared for desktops. And how to download and install the IoT Core on your device. You just simply get the IoT dashboard app, which is small app, and then you go to set up a new device, which guides you through all the installation process. So it's like pretty straightforward, and you can quickly deploy Windows 10 to your device, and then you can even try some sample applications to get some idea how does it work. So typically when you work on some project, typically when you want to try something new, most likely you will be afraid that it may consume a lot of time. But with this guy, with Windows 10 IoT Core, it's really pretty fast. So you can like set up your device very quickly and then start working with the code. So one may think that since this device is using the Windows 10 IoT Core, people may think that it's just for fun and you can simply use it for blinking an LED. But in reality, you can write even more advanced apps which gets an access to sensors on the board, on the SenseHealth board. Specifically, here is the example of reading data from the accelerometer. So how is it possible that I'm using the Windows 10 IoT Core and I'm using the API, which is also available for other platforms? So basically, the Windows 10 was designed in a way that there is some core software development kit, which is called the Universal Windows Platform. And there are specific extensions for each platform. So there is a core, and then if you target desktop, you have some extra extensions for desktop apps. If you work with mobile or Xbox, you have also appropriate extensions. And if you want to work with augmented reality, HoloLens, you use holographic extensions. And finally, you have extensions for the IoT, which can be used for reading data from sensors, for example. The Windows 10 and the Universal Windows Platform follows the write once, run everywhere paradigm. And basically, it means that you have one code. Here I have the XAML code, which defines the UI of a sample app. It has 2 buttons and 1 figure. And now, by simply choosing the target platform, I can quickly compile and run this app either in the AR emulator, HoloLens emulator, on the desktop, or on the mobile device emulator. And basically, I don't need to change anything in my logic, provided I don't want to tailor the logic to the particular platform. And the app will automatically adjust to the specific platform. So going into more details about the image acquisition, since I have the single core, I can do it the same on any platform supported by Windows 10. So there is a media capture class, which I need to initialize by saying what is the streaming mode. I can either stream the audio or video, and I can also point the device which I want to use for capture. Then I have, so here I have the settings which I pass to the media capture, and then this acts as the main class which acquires data from the camera, and then the image is displayed in the capture element. So if I want just to capture a single frame, what I need to do is to prepare the encoding properties then create the memory stream, and capture photo to stream using the media capture class, and appropriately decode it to a bitmap using my encoding properties, and then return the bitmap for further processing. So this is when I want to capture just a single frame, where I have more advanced processing loop, specifically for machine vision. I have one-time initialization, then I create and configure my media capture object, and using the image provided by this object, I send it for processing and then perform the acquisition loop. So, for example, in case of the emotions API, I send the image to the cloud, and then I get the JSON, which is a text file, in which I have a single object which gives me the face location in the provided image, and also the scores, which are the probability of the given emotion in the image. So as you can see, you have several emotions detectable by the artificial intelligence. And then to detect the mostly expressed emotion, you just take the one with the highest score. Here, the surprise has the highest score, so I display the surprise on the image. So how does it work? It's really pretty simple, because you have the client, REST client, which sends those requests to the cloud for you. So as you can see, I just convert my bitmap to a stream, send it to the cloud using the emotion service client, and then pick the first recognition result. And also in the Microsoft Cognitive Services, you have additional clients, additional algorithms implemented. For example, in the Vision API, you have the algorithms which can process the image content. For example, when you send the image like that to this artificial intelligence system, it takes the image as an input and describes what is the content in the image. And in this case, it detects that this is a man wearing a hat with a score of 61%. When I sent this young lady for processing, the image of this young lady for processing, I got the result, a young child wearing a shirt and tie with a low score of 16%. So what's the conclusion? The conclusion in terms of these images, the conclusion is that some people are predicting the future use of the Internet of Things, but actually the Internet of Things and the artificial intelligence is being used right now. So you can, and moreover, you can very easily attach it, use it in any app you want, provided you have the access to Internet, and you have and you can use any REST client you want. Okay, going back to details. So when I have the video capture for custom processing, I have a method which is called in the background thread in a loop. It acquires data from the webcam. Then I call the method which processes the image, and then this method tells me what is the largest detected, what is the description of the largest detected object, and then I display this information on the screen or on the LED array of this small device. And how I did the custom image processing based on OpenCV. As you know, the OpenCV is a well-known image processing library, and one of the interfaces for that is the C++. And how to connect the C++ with the Universal Windows Platform, which basically in all these examples was programmed and interfaced using C#. So I have my C# app written for Universal Windows platform. And then I have a very thin wrapper written in the C++ component extensions. And in this wrapper, I directly call OpenCV native libraries, which are interfaced with the wrapper using standard techniques. So I have all the headers and libs included here. And then when I want to use the OpenCV functionality in my UWP app, I simply call these methods through this wrapper, the same as I would be using any other C# library. And when you work with the custom image processing, which aims at detecting some objects, the first thing you typically do is the thresholding, image thresholding, in which you convert the either 8-bit or more an image with the more depth to a binary image, which contains just the two values, 0 or 255 or 01, depending on your detailed image representation. And here is the example of calling the odds-to thresholding from OpenCV through the C++ component extension wrapper. So I process the Lena image using this method. Here's the method from my C++ CX wrapper. So it just first checks the input parameters if they are correct. And then I need to convert the image data from the writable bitmap, which is the UWP object, to mat object, which is used internally in OpenCV. Then I also have a working buffer, and then perform the threshold by simply calling the threshold function from OpenCV library, and then make some color conversion and release the resources. So then, using this thresholding and some additional techniques, I can detect contours of the objects in the image. And this is again done using the OpenCV library. Again, I'm checking the input parameters, converting the writable bitmap to the mat object, find the contours, and draw the contours on the image. The finding contours is done in the following way. So I firstly threshold the image, then find the contours using the find contours method, and I can of course use all of the parameters and algorithms available in the OpenCV, and then simply draw the detected contours on the image. And here is the working example of this processing. So I was recording that last night in my room, so it was pretty dark, but what I want to show you is that I print out the simple geometrical shapes on the piece of paper and then put it in front of the camera. So I detect the contour, infer what's the object type, and then display this object on the simple display I have on my Things device. So as you can see, the detection implemented in OpenCV is pretty robust. I don't need to implement everything from scratch. I can rapidly develop the machine vision system, so I don't need to spend time for implementing very simple operations. I can use the very good processing library, and moreover, I can easily integrate it with the high-level software, high-level API from the Universal Windows platform. So by going to summary of all these developments, I'd like to present some case study about the project which I was working when I was a PhD student. And this project aimed at development of the device, eye imaging device, which scans the interior and posterior elements of the human eye. And basically, it was done using the non-invasively, using the near-infrared light. Near-infrared light was penetrating your eye and producing the image on the display. And this project was done in the following technologies. So firstly, we used the C# Windows Presentation Foundation as our presentation layer and user interface layer. And since we control the device, this device from the PC, when user taps any button on the screen, it triggers some action, for example, eye scanning performed by the device. So this information needs to go to the eyes imager through PC and through firmware implemented on the PCBs. And those PCBs were directly controlling the scanning and all the operations performed by the hardware. So the problem was I was working in the middleware layer. So then we used what kind of problem did we have here? So as you can imagine, since we have like 3 printed circuit boards, which are developed using the systems and development environments, which I completely have no idea about, it was difficult to communicate with farmer engineers, especially when we had to directly interface our code with theirs. Specifically, when we need to send some command to the device, we had to face a lot of issues. And in my opinion, the largest issue was that we were using completely different tools and we were unable to efficiently communicate and understand our problems. For example, when I was doing the middleware, I had the Visual Studio, which is a pretty neat IDE. So I have a debugger and everything what I need. It works very good, no crashes. So for me, it was very difficult to understand that farmer engineers have some old tools which they cannot tailor for their needs completely. So now, if I were given the task to build the communication between the board like that with the PC, I would use the Windows 10 IoT Core on both ends and virtually write the same code for this low-level device and for middleware. So me as a single engineer would be able to sort out all the communications, which was the bottleneck of this project. So the final conclusion, according to my experience and what I've shown you today, is that this communication layer could be done much easier given the Windows 10 IoT Core. And the final conclusions are the following. So firstly, Windows 10 IoT Core can be used for rapid development of IoT solutions without starting from scratch. Of course, you may not always use it when you need like very fast response or of course, I'm not saying that Windows 10 IoT Core is the solution for every problem. Naturally, all the problems has to be solved by choosing the best solution, but at least if you want to try something or rapidly develop some proof of concept device, you can easily do it with the Windows 10 IoT Core. And this can be, of course, used for the programmers, but also by students, researchers, enthusiasts, engineers, and scientists. And if you are a web programmer or mobile programmer and want to try something different, the IoT Core can be also a good start for you. And my last slide is to thank you for your attention. And here I would like to play the last clip, which shows the real-time audio processing implemented on this board. So I take the wave as an input and then process it using the fast Fourier transform to determine the spectrum of the audio and display it in real time on the LED array. So thank you very much for your attention and looking forward for your questions.
what actually framework do you use for machine learning? Do you use OpenCV as such, or you process your data with TensorFlow or Tiana?
Yes. So basically, I use just for this example, I use the Microsoft Cognitive Services, which is like it's already pre-trained set of machine learning algorithms. But the next, so basically I don't need to do anything to detect the emotions, but of course it's not the solution for every problem. When you want to develop your own model, train your own model, you can use the, Microsoft also has the Azure Machine Learning Studio, which is a web-based app where you can upload your data, train the system using some already implemented algorithms, and deploy it as a web service, and then you can like tailor. Then you can like train the machine learning on your own. And also it has it can process the R scripts. So if you are the data scientist, you can also use your R scripts.
I've got a question about the supported platforms for this Microsoft IoT's toolset. Is it Raspberry 2 or 3? And what are
what are the other development boards, right?
Yes.
Oh yes. So you have one from Intel, Mino board, Intel Joule, as I remember correctly. Of course, you don't have like many boards you can deploy the Windows 10 IoT Core. You have like maybe 4 or 5 currently, but I don't remember the names of all of them.
Thank you for the presentation. Just a question out of curiosity. Have you ever considered not Windows platform, let's say all kind of Linuxes that are available for those boards?
Oh, so I cannot give you, I cannot tell you which one is better.
No, I'm not talking about that. I'm just curious about one thing, because if I remember correctly, Windows 10 Internet of Things is actually limited because it doesn't have a GPU support. And GPU is way more powerful on those boards. I mean, definitely on a Raspberry Pi. I was also thinking about the other board, which is based on NVIDIA Tegra.
Oh, so actually I haven't tried GPU processing for IoT, but so it's a very good question then. So, but are you thinking about the Raspbian or something like that?
Anything that has GPU support, because actually the goal for me would be a GPU access. OS is sort of like a tool to achieve what I was looking for. I'm just curious because GPU is available definitely on Raspberry Pi, and if I remember correctly, it's way more powerful than the CPU that is there.
Okay, so I don't think the IoT Core currently supported, but I hope it will support it pretty soon.
All right, thank you.
Thank you very much.